In this video we're going to look at passing parameters by reference. Now we're going to use this little piece of C code here. It doesn't matter if you haven't written any C, the nomenclature of the language is not important. Now what we're going to do in this little piece of code is we're going to set aside a variable called num1 and we're going to put the value 10 in num1 and we're going to have the variable num2 and it will hold the value 20. And then we'll take these numbers, we'll pass them into this little function called swap, and it will swap them round about so that num1 will then become 20 and num2 will become 10. So we just swap the values round. Now what's important here is that in the previous video, whenever we passed values into our subroutine, we passed an actual value, meaning the contents of a memory location. So that would be equivalent to, for example, in this example, passing the number 10 and the number 20 into the subroutine. But that's not what we're going to do here. What we are going to do is pass the actual variable as opposed to the value of the variable. So we'll take a little moment just to consider this. There's a difference here between num1, which is the variable, and the number 10, which is the value. Num1 refers to the memory location, and number 10 refers to the value stored in that memory location. So those are two different things. When we define a variable, we define the address of a memory location, and the value of that variable is held within that memory location. So that's very important, and it's a thing you should take note of, the difference between a variable and the actual value of the variable. The variable is the memory location and the value is the contents of the memory location. So whenever we run this little function here, we don't pass in the number 10 and the number 20. We pass in num1 and num2. Num1 and num2 are the address of number 10 and number 20. So we pass the addresses into the function. Now, the reason why we pass the addresses into the function is that the num1 and num2 values actually exist in memory. Okay, they're variables, they exist in memory. So it means that if we were going to swap the two values round about, we have to swap the values in those two memory locations. So what the function needs to know isn't what the values are, it needs to know where they are. It needs to be able to go and find the values within memory. Now, whenever the function has gone and found the values within memory, the actual assembly language code that lies below the function is then able to go ahead and do the swapping of the values. So that's why we pass in the actual memory locations and not the values. So we are passing in by reference. So what we're really saying is we are referring to the numbers 10 and 20 via the addresses of the number. So that's why we say we're passing by reference. We're passing the addresses which refer to those numbers. Now we'll quickly finish off this page here, and don't worry too much if it's difficult to follow. We will go through the example in assembly language. We will load it into our machine and we'll see the whole thing running, okay? So you will see the whole thing. Now, whenever we've passed our addresses in, we can then go through, the function can then go through the swap. So it will go to the address of the value A. Now it can't just swap the two values round about. It can't say, we'll take the value that's in A and we will copy over onto the value that's in B, and then take the value from B and put it in A, because you're writing over it. So if you take, for example, the number 10 and 20, if you take the number 10 and you copy over into number 20, well, you've overwritten the number 20, so you can't take the number 20 and copy it into number 10. So you need another method of doing this. So another way of doing this is to have a temporary memory location. So we set up another memory location called temp, and of course that is just a variable again. So we've got a variable called temp, and we can put the value A into temp. So we can put 10 into temp, and then we can make the value A is equal to B. So we can take B and put it into the value, the memory location A, and then we can take the value that's held in temp and we can put that into B. So then 10 will get into the position that was held in 20. So that's the way we shuffle the numbers about in memory in order to swap them round about. So that's enough of us talking here. Let's go ahead and we'll look at the assembly language and we'll see how we do it in our assembler, and then we'll put it into our machine. Now I've gone ahead and generated the assembly language, which will allow us to run this function on our CPU. Now we'll start off at the bottom here with the start address. So that value is 0 x 8100 in hex, and it's going to hold, or addresses that appear below that address are going to hold all our variables and constants. So we're going to have the directives DS1, DS2, DS3. So this is our define storage directive, and also our DC, which is define constant directive. So we're going to set aside 3 memory locations for 3 variables, which are going to be address of A, so that's address of the number A, and address B, which is the address of number B. And we're also going to set aside another storage location for temp. So that's us set aside in effect 3 variables, address A, address B and temp, and they're each of 1 byte long, meaning 16 bits long. We're also going to set aside our values for our A and our values for our B. So our A is going to have a value of 10 and our B is a value of 20. So we've seen that from above. So this is really this line here. So integer num1 is 10, integer num2 is 20. So these can really just be directly related to this DC command here. Now the way it works again is that address A will be the value 8100, address B will be 8101, temp will be 8102, and the A will be 8103, and the B will be 8104. So that's us set these values aside. Now the first part of this is the call to our function. So the bit at the top here is really the part here, which is our request for the function. So we're going to pass our parameters into our function. So the parameters that we're going to pass in here are the value, the A and the B. But the A and the B, remember, are addresses. So these are going to be the addresses of the values A and the value B. So that's going to be, in this case here, it's going to be 8103 and 8104. So 8103 and 8104 are going to get into the registers R0 and R1. So that's us passing in our address. Okay, so that's very important. Now we didn't pass in the values 10 and 20, we passed in the address of the values 10 and 20, and that's the passing of in the addresses. They go in via the registers R0 and R1. So now we've set that up, we can jump to our subroutine swap. So this jumps down to our subroutine, and now we're ready to start our subroutine. So this part of the code here really is the part of the code here, which is an actual swap. So let's talk through this part of the code here. Now, in order to cover this section here, I have added in an extra little part into the previous page, and we will fill this in as we go along. Now, whenever we start off our program here, we're going to have the number 10 and the number 20 in memory locations A and memory location B. So we can get our memory location from the start address. So that's going to be 8100, 8101, 8102, 8103 and 8104. So it means that 10 is going to be in 8103 and 20 is in 8104. So we're going to have a value of 10 in this memory location and a value of 20 in this memory location. Now, whenever we started it off, we said we're going to be passing the addresses into the function. So we can see here that we've set it up here with the putting a value of A into register R0 and B into register R1. So this A and B refer to these memory locations. So the memory location here for A and B is 8103 and B is 8104. So these two here put 8103 and 8104 into register R0. Now, we pass these values, which are memory locations, into the function. And we then grab those values inside the function using this store command. So we grab the value R0 and we put it into address underscore A, the value in R1 and we put it into address underscore B. So the values here are going to be the 8103 and 8104. So we take the 8103, 8104 and we put it into this address A and address B. So the address A is going to be the first DS here, which is 8100. So what we're going to do is we're going to take these memory locations 8103 and 8104 and put them in here. So that's going to be 8103, that's going to be 8104. So you can see here at the side I've wrote address A, address B. That's our original value for A is 10 and B, and the original addresses for A and B 8103, 8104, and this is the temporary address which we set aside. Now, in order to work through here, you'll see that what we're going to do is we're going to use the first of our more exotic instructions, okay, and this is a pointer instruction, and what this instruction does is it says load the contents of this memory location into R0. But then you have to say, well, what are the contents of this memory location? Well, it's an indirect addressing mode, and this refers to a pointer. So what it does is it says here, go to the address A. Now, address A, we see here, we know which address of this, which is 8100. It's just the first line here after our directive. So we go to 8100 and then it finds the value 8103. So this 8103 is a pointer to another memory location. That's why we've got our square brackets round about it. It's an indirect addressing mode. So this 8103 points down to this memory location. And then it pulls the value from this memory location and out. Okay, so it pulls the value 10 out and it puts it in register R0. So it means now we're going to have 10 in register R0. And then we copy the 10 from register R0 into the temp. So we take the 10 out here and we put it in here. So this in effect is this line here. Now we then go down here and we get our other value. So we load address B into register R0. So again, address B here now is going to be this position here, which is 8102. So it goes to the 8101. So it goes to 8101. It finds the number 8104, goes to 8104, pulls the value 20 out, and it becomes their new register R0. So register R0 is now the value of 20. Now we take that value 20, which is in register R0, and we store it in this address here. Now what is this address? Well, it's going to be address A, which is the 8100. But it's a pointer address or an indirect addressing. So we're going to put the value 20 not in this address, but the address pointed to via this. So it goes to 8100, it pulls out the address 8103. It goes to the address 8103 and it copies the 20 over onto this address. So now that no longer contains 20, no longer contains 10, it now contains the value of 20. Now we load R0 with the contents of temp. Now the contents of temp are going to be the number 10. So R0 becomes 10. And now we then go ahead and we store the contents of R0 in this address here. So we're going to store the contents, the number 10, in address B. So the address B here is this value here, 8101. That's the address B here, and it gets it for this number, 8100, 8101. So it goes to 8101, finds 8104, goes down to 8104, and it puts that number there. So it now puts the number 10 in here. So in effect, that's us finished our program. We then return back up to the next line after the jump to subroutine, which is the end, and that's us finished. And when we're finished, you can see now that we have indeed swapped the two numbers over. Originally we had 10 and 20 in here, now we've got 20 and 10 in here. So let's go ahead and we'll actually see this working on our machine. Now we're going to start off with the number 10 and the number 20 in the memory location given by A and B. So these memory locations are going to be our 8103 and 8104. So we'll go ahead and we'll do that. So again, it's best if you actually download this and run it for yourself, and you can see all of the changes happening, and you'll see it happening a lot quicker than you actually see here. So that's us put the values in. So if you come down here, we've got the first one in, which is A. So we've got A in that memory location, which is the number 10. And if we continue, and this is us putting the value of 20 in the next memory location. So that's us got 20 in the mixed memory location here. So we've got our 10 and our 20 in our original memory locations. Now the next thing that we're going to do is put the value A into register R0. So the value A is the actual memory location. So we're going to put the memory location of this number, which is 8103, into the register R0 and the memory location here of this number, which is 8104, into the memory, into the register R1. So you'll be able to see those going in just now. So that's 8103 and that's 8104. Now we're ready to go to the jump to subroutine. So that's us now jumped to the subroutine, and we're ready to take our first instruction from the subroutine here, which is 800. So our first instruction in the subroutine here is the store R0 in this address A. So we're going to take the 8103 and the 8104 and we're going to store them in address A and address B, which is the 8100 and 8101. So we'll go ahead and do that now. So that's instruction 800 and instruction 810. So if we come in here now, you'll be able to see that those two values, which are 8103 and 8104, are now sitting in these memory locations. So that in effect is us past the values by reference. We've passed in the memory locations of the information that we're interested in. We're interested in these two numbers and we want to swap them, but to swap them we have to pass the memory location of these into the function, and that's us pass the memory locations into the function. Now if we continue, you'll see that we're going to take the number 10 and it's going to get into register R0, and we'll take the number 10 and then we'll put it into the temp. So we'll go ahead and do that now. So we should see the value 10 get into register R0. So that's the value 10, which is A. And then we have to take that value and we have to put it in the temp memory location. So if we can in here now, the value there should be in the temp memory location. So you can see that we've taken a copy of that A and we've had to put it in the register and then bring it from the register and put it into the memory location. So we've got a copy of 10 in the temp value. We then have to take the value of 20, which is this one, and then we're going to copy that value of 20 into this location here. Okay, so we'll do that in the next phase. So again, it's going to take the 20, which is 14 in hex, and put it into R0, and then after that it'll copy that and it'll put it into the address A. So let's have a look and see. We should be in here now, and you can see here it's now taken that value and it's put it into the address A. Okay, so we've taken a copy out and put it in there, and we've taken this value and we've put it in here. And if we continue this, we're going to go to the final part of the code, which, if we look at the final part of the code here, is going to store the value R0 in address B. So I'll continue along to the end of the code here. And it should, I'll wait till it actually goes to the end and we get our end coming up. So that's our end command here, and you can see whenever we get in here, we've now got these swapped round about. So we originally had in here, we had the value of A, and in here we had the value, the 14. So that was our value 10 was in here, and our 20 was in here. Now we've got our 20 in here, and our 10 is in here. So that's us going through this swap process. So it shows you the complexity that we have in order to generate these functions. But you have to remember that once you've generated this function once and you know how it's done, this can then be generalized to all functions of this form, and it can be expanded up to functions of any numbers of variables. So it's difficult to get started on it, but once you've done one, the rest of them are just a slightly different but pretty much the same sort of theme. Okay, so by learning this stuff, I would suggest to you, going through it in this sort of detail, that you've actually learned an awful lot, and it's a very, very useful stuff to know. So that's been a long and difficult video. I don't want to keep you any longer. In the next video, we'll look at passing values via the stack. So thank you for listening. I'll get you on the next video. Goodbye.